MicroVAX family has been one of Digital's most successful product lines. In the past 4 years, Digital has sold nearly 200,000 MicroVAX systems to customers all over the world. When the MicroVAX 2 was introduced in 1985, it revolutionized the computer industry. For the first time, a powerful 32-bit computer with lots of software and software development tools was available at an affordable price. To learn more about the history of the MicroVAX family and its future, we take you to Digital's mill building in Maynard, Massachusetts, the home of the MicroVAX. Here we will meet the head of the MicroVAX business, Jesse Lipcon. Jesse is one of the many digital engineers who have graduated from the Massachusetts Institute of Technology in nearby Cambridge, Massachusetts, and he is often referred to as the father of the MicroVAX.
I joined Digital back in 1972. At that time, we had only about 8,000 or 10,000 employees. The company has now grown to over 120,000 employees. Perhaps more important, back in 1972, the business was primarily a U.S. business. Even in 1985, when we announced MicroVAX 2 and ramped MicroVAX 2 to high volume, the business was still about 2/3 U.S. But over the last few years, most of the growth has occurred outside of the United States, and the MicroVAX business today is running about 45% U.S. business and 55% non-U.S. business. Within that non-U.S. business, Japan is extremely important as a high-growth area for MicroVAX, and that's why I welcome the opportunity to speak about MicroVAX with you today. Back in the early 80s, we had this wonderful corporate strategy of winning in the marketplace by having the broadest range of compatible computing on the VAX family. It was a wonderful strategy. What was not so wonderful before the advent of MicroVAX was our implementation. It was quite apparent back around 1982 or so that the industry was on the verge of being able to put full 32-bit processors with the performance of a VAX 11780 capable of running virtual memory operating systems on a single chip. And unless we did the same thing, this wonderful strategy of a broad range of compatible VAX computing would have been just that, a strategy, but we would not have had the implementation tactics. We would not have been able to pull it off. So, recognizing this, a team in our VLSI group in Hudson, Mass. Went off to develop the MicroVAX chip, a single chip implementation of the VAX architecture. We like to say the first 3 goals on our list of goals for that product were time to market, and time to market. We perhaps had a bit of a late start, and we recognized that the competitive 32-bit single-chip machines were coming, and we had to make up for that late start and beat them to market, and we did. And perhaps more important, when we came to market, we brought into the under $50,000 price band the full capability of the VAX architecture, the VMS software, and more important, the thousands of applications that existed on VMS. So we really brought to bear at day one perhaps more software than had ever been available on a machine in this price band. The major impact of the MicroVAX family on computing in general, I would say, is that it really legitimized the concept of distributed computing. It was a wonderful concept before. We had, of course, been shipping DECnet products since before the advent of the VAX family. But it was really a connectivity solution. If one had a handful of machines around a facility or perhaps in different cities, you could network them together, but it was not real distributed processing. And by virtue of the ability to take a machine whose power approached that of a VAX 11780 and make it very cost effective, all of a sudden you could afford VAX functionality, VAX performance in much higher quantities than you did before. That opened up applications for large projects, for example, where VAXs were put in multiple departments of an organization, multiple stores or branch banks, and I think contributed to really the explosion in distributed processing that we've seen through the second half of the 80s.
Digital was able to build on the success of the VAX 11780 and the PDP-11 by using such components as enclosures, I/O bus structures, communications devices, and the VMS operating system digital engineers were able to design a system that would not only meet the time-to-market goals, it would be fully compatible with Digital's other VAX products. Lou Philippon, manager of the MicroVAX Product Management Group.
We found in the PDP-11, micro PDP-11 packaging, the packaging that we needed. We found the Q-bus, we found the disks and the tapes and the communications. We created our processor board, one single quad size, about the size of a sheet of paper. The goal was to reach the office. The goal was to create a department computer, a system capable of handling not one user, but many.
Immediately after the announcement, MicroVAX 2s were rolled into offices all over the world. The MicroVAX 2 was the right product in the right place at the right price. Overnight, it became one of the most successful new products ever introduced by an American company in any industry. While the MicroVAX 2 is nearing the end of its useful life, 3 new MicroVAX systems are quickly taking its place in the market. The new MicroVAX systems are cheaper, faster, more reliable, and have much greater storage capacity than the MicroVAX 2. The high end of the new MicroVAX family includes the MicroVAX 3800 and 3900 systems. Both are 4 times faster than the MicroVAX 2. MicroVAX 3300 and 3400 systems occupy the mid-range of the MicroVAX family, with 2.5 times the performance of the MicroVAX 2 for about the same price.
With the introduction in October of 1988 of the MicroVAX 3300 and 3400, we introduced a new I/O structure called DSSI, which is the interconnect for our high-performance RF disks, the RF30 and the RF71. What the DSSI is doing is offloading the mass storage traffic from the Q-bus onto the DSSI, which we directly connect to the CPU board. And what that has done is bought us at least 2 and perhaps 3 more generations where the Q-bus, with its 3.3 megabyte per second of bandwidth, will really suffice as the I/O structure for the MicroVAX family. I have a model of I/O buses which says basically, due to the level of investment, the billions of dollars in hardware designs invested in buses, they have to last for about 20 years. The Q-bus came out in about 1975 or 1976, so we have several generations yet to go. And by moving the mass storage traffic and the networking traffic off the Q-bus onto the CPU board, we've given it that last kick, which will extend its life well into the 90s.
This new storage technology brought dramatic improvements in I/O throughput and introduced dual-host systems to the MicroVAX family.
The dual-host capability has been designed for many reasons and for many uses. But the primary reason is to provide higher availability, higher access, greater file access to your files in the event that one CPU found in one host or in one system were to crash. You as a customer, you as a user, would still have access to your files and to your applications by way of the other CPU, and where all files actually are on the DSSI. The DSSI is a high-speed bus that has rated at 4 megabytes per second. It is independent from the Q-bus and independent from the Ethernet. So it's a high-speed bus connecting 2 CPUs. As a high-speed bus, it has the ability to handle 8 nodes, or 8 locations. 2 of those locations are taken up by 2 processors. The other 6 locations are taken up by the disk drives, which we refer to as integrated storage elements. In each of the integrated storage elements, there are most of the characteristics of an HSC controller. Therefore, every time you add a an ISE, you add an RF30 or an RF71, in other words, you are adding another controller. What does that mean? It means that you have linear performance. You are adding linearly to your QIO capabilities every time you add an RF30 and every time you add another RF71.
What's nice about dual host configurations is that you can have each of two different CPUs share a string of DSSI disks, so that if one CPU fails, the other can take over. If you use this dual host configuration, for example, as a boot node in a local area VAX cluster of diskless workstations, a user on any particular diskless workstation, other than seeing a short pause, is not even going to be aware if the host that he was using as a file server goes down. The work just fails over to the other host transparently, and that user can have access to all his files. And of course, most of the time, 99.9% of the time, both CPUs are up and running, so you see the performance boost of having two CPUs instead of one. It's really a nice high availability situation. Not what you would call non-stop fault tolerant, but for much lower cost than true non-stop fault tolerant computing, it gets you most of the way there.
In July of 1989, Digital unveiled the newest members of the MicroVAX family, the MicroVAX 3100 and VAX Server 3100. Designed to be sold in large volumes, these are the lowest priced VAX systems ever.
What's really nice about the MicroVAX 3100 is in a single box solution, you can get mass storage, 104 megabyte disk, and mass storage expansion in the large box up to 3 more 104 megabyte disks. You can get the tape backup, the TZ30 tape, which was developed in Tokyo. In that same box, you can get communications expansion up to 12 asynchronous lines and 1 synchronous line, all in the same box, and it's got a universal power supply. It works on 110 volts or 220. In fact, you don't even need a switch. It senses which voltage it's plugged into and just adjusts itself accordingly. We think that some of these improvements will really result in the MicroVAX 3100 being a far more attractive product than the MicroVAX 2000 it replaces. And we have high hopes that it's just going to take off and open up whole new markets in distributed processing, wide area networks, replicated branch banks, retail outlets, insurance offices, any application where you want to field a large number of very small systems and then tie them all together with a broad-based network. In particular, it'll be a great machine for PC integration. What's exciting about the technology that we're using in the MicroVAX family is that it's on such a very steep performance curve at relatively constant levels of cost. In fact, if you trace back the history of the performance of single-chip CPUs back to about 1970, when the first single-chip CPU came along, what you find is a consistent factor of 1.5 improvement in performance every year. And that has now been going on for about 20 years, and there's no end in sight. It's certainly going to go on for the next 10 years. VLSI technology is improving not only the CPU and memory subsystems, but also the I/O subsystems. It was VLSI that enabled us to put the DSSI adapter onto the CPU board off the Q-bus. It's VLSI which has enabled us via single-chip Ethernet adapters to put the network traffic off the Q-bus onto the CPU board. But perhaps equally important, VLSI has enabled us to get the Q-bus adapter itself down to a single chip, which freed up the real estate for all this other functionality we're putting on the CPU board. I'm very happy to say that we worked very closely with the VLSI group in the Digital Japan R&D Center in Tokyo, and they actually developed that single-chip Q-bus interface, which we have used in the entire MicroVAX 3000 family, and which we will be using in subsequent generations of MicroVAXs as well.
MicroVAX systems are an integral part of Digital's computing strategy. They are designed to be fully compatible with all of Digital's products. In Japan, there are many opportunities for MicroVAX. Many customers are using PCs and workstations from several different vendors. They need to protect their investments. they need to integrate their systems into work systems. Big customers will use MicroVAX systems to integrate PCs and workstations in departments and work groups throughout their organizations. The entry-level pricing is low enough for them to afford at least one VAX for every department or branch location. Smaller customers will use MicroVAX systems to integrate their PCs and workstations or as main computers. With the price performance of the MicroVAX and our unique ability to integrate systems from multiple vendors, Digital has the best solution in the industry.